the pieces कि प्रॉब्लम स्टेटमेंट को दो पार्ट में डिवाइड करें, ठीक है ना. फर्स्ट इज लाइक दैट transactional processing using system deployed in their own stores. So, own store word is like it's not in the cloud, correct? जरूरी नहीं है कि क्लाउड में हो, बट दिस ट्रांजेक्शन इज लाइक कैन बी हैपन ऑन द स्टोर. और जो भी डेटा है मीन्स लाइक once transaction is done, they can send the data to outside. So
Mega marine stores do most of the transactional processing using the system deployed in their own store. Each of the stores have individual computer and data stores. There is a need of a system which creates a global view of data across all stores in a near real-time fashion on the cloud. This cloud system should be able to provide a global view of transactional data across all the stores. The systems should also be capable of supporting multiple client needs, access to the global view, and also feed downstream systems like cold storage to avoid cold storages being fed from various stores. So what meaning is basically each store is having their own system, means their own application. Right? Yeah. So basically what they want is, let's say there are 5 stores, S1, S2, S3, S4, S5. Let's say 3 stores, S1, S2, S3. Right? So what is happening is the store will be selling those goods or something, whatever is happening, that is their own applications are already there. What is happening is basically need is all these things should come to a central location, and this should also showcase to the let's say business analyst or some management team a dashboard of the real-time data.
Yeah, exactly right. Yeah.
And supporting multiple clients needs to a global view. Basically the global multiple clients, maybe stakeholders, maybe global view. Also downstream systems like cold storages to avoid cold storage being very special. Okay. So basically it will be having this S1, S2, S3 are the upstream systems where the data is coming. So here after all these things, maybe the data also should be exposed to downstream systems so that they can consume and utilize this messages, whatever aggregated or the message data.
Yeah. So I mean, like in high level, if you want to see like the situation is, these are the left hand side part. These 3 are like online stores.
Correct.
Where transaction is happening. So this part where my arrow is there, this is like that S1, S2, S3, and take this part as a cloud, and after that I am feeding the cloud data in the form of dashboarding or web UI or thick client or anything. Means like basically this is the dashboard where means like all means like there is a statement now, global view across the all storage basically, all stores basically, okay na? So this one, these users, this BA, you can say BA, or you can say like that any BI user, business analyst here, or the data analytics user, real-time view they are getting. Real-time view means like
yes,
means like earlier we discussed about there was a hard, there was a soft, and there was a near real time. So where we talk about second and few second, kind of second and millisecond basically.
correct.
Yeah. So in seconds generally we take it as a real time. And when we talk about that the soft, it means it is millisecond, and when you talk about hard, then it is a microsecond. If we will in the range we will consider, so it will become like soft will become like
soft is basically near real time. Last time I told it is in seconds.
Yeah.
Like the Skype or Google Meets and all. And soft is in milliseconds, like we have the IoT devices and all. And hard is in microseconds, like our pacemaker.
Pacemaker, yeah, exactly.
So here it is near real time means basically we are talking about the category 1, that is in seconds.
Yeah, that is in seconds. So basically you are transferring your data from that on-premise to cloud, and then after that you are nurturing your data in such a way like that the users can understand the data. It's like not only the view, but they need to be able to understand. So basically here, this is representing a complete ETL pipeline. So yeah, means like from here to here, exactly what I am doing, that I am uh, doing the extraction, transformation, loading. Yeah. Now there was the one more word like cold storage, so that we can discuss later, because it is kind of a data archiving process where I want to make it sure that my data must be available. Uh, yeah, means like for future usage. It's not just only that, okay, uh, I no need to delete the data basically. So yeah, uh, we will talk about the cold storage later, but near real time is the same thing what we discussed just right now, that processing the data in seconds, but it should not be like in minutes or hours, not. So we need to transfer the data in such a way like that via extraction without a latency. We need to process or transform this data uh, in the seconds or millisecond, and when it is arriving to the final destination, it should not cross the more than 10 steps. So this we will discuss later, but this is the high level diagram. Okay. So now there are some main points like near real-time cloud storage of all store specific transaction data. Near real-time cloud storage of all store specific transaction data provide a global view of ordered transaction across all store. Order-based search for the transaction data across all store customer by more than one application client. Data should be made available to downstream cold storage for longer term. So there are the two kind of architecture in means like data engineering. One is called as the Lambda architecture and another is called as the Kappa architecture. So don't get confused with the Lambda word by AWS Lambda. Basically the Lambda architecture is like uh, how you are processing your data in such a way like that you are doing analysis in the real time, as well as you are storing that data for future, for like big data kind of concept where you can analyze the data like 1 year data, 2 years data. So it is called as a cold storage, where like you are not paying much money to store the data, as well as you can mine it later for the long term storage. So that is called the Lambda architecture.
So there are two types of architecture, means ETL architectures.
Yeah, we can say, yeah, that is true, that we can say like ETL
Okay, one is the
architecture.
Lambda, another is Kopa.
Kappa.
KOPA and COPA.
This is KPPA, Kappa architecture. So this one, if we will talk about that, the Lambda architecture. So you are having the multiple source here. So take the source, all the source here. Give me one moment. Okay, I'm just taking one store here. Instead of saying that store, I will just say like the data source. So it could be anything. So the requirement is saying that you should be able to use it for the future purpose. So suppose we are having the multiple data source, means like multiple stores, correct? And if I'm having a layer from here to here, I will just say like that the left hand side part is my uh, is my source provider, data provider basically, and right hand side is like how I am going to process it. So Lambda architecture says like that, okay, doesn't matter how you are getting a data, but main thing is like that once you are getting the data. So for an example, this guy is acting as a consumer. This guy is the consumer, correct? Consumer in the sense data consumer, or you can say like ingester kind of things. So here in that part, like left hand part,
Are you writing something?
you are not able to see.
No, I'm seeing that data source.
Okay, give me one. Yeah, that one only. So You are able to see my
Just move.
cursor.
Oh, now it is refreshing. Okay. Data source, then consumer right hand side. Okay.
Yeah. So here it's like that data is being fed. I'm not talking especially like it is a cloud or something, because ETL can be on-prem to on-prem. Okay. So I'm just trying to say like that, okay, this line is just trying to divide the left-hand part as a data provider, and the right-hand part is like how I'm processing my data, how I'm ingesting my data, how I'm transforming my data, and how I'm loading my data. So if I'm consuming this data and I'm making it available in the real time, so this is called as a real time processing and making data available for further use. But when I'm saying that real time processing means the end user should get in the seconds, correct? As well as Lambda architecture says like that you should process the data for future use as well, but in such a way like that you are not compromising with your data processing speed for real time processing. So basically this one I will just say like that it is for kind of big data concept. And now if I will take the users, yeah, this is the user which is like which need all the information in the real time. Okay, correct. But it might be possible that you need some data from this guy, means like might be it could be like master data, it could be like 1 year data which is getting influenced and which is required to process something here. Okay, for an example, uh, suppose these are like that the taxi data is coming, okay, that Uber 1, Uber 2, Uber 3, 3 taxis coming, and this is the consumer. So the use case is like that here this is the data, means like here is like we are taking a decision. So what is the decision? Decision is saying that uh, all three are in the same distance from a customer. So if I will take a customer, okay, so this is my customer, or I'll take this is the customer, this is the customer. So I need to assign one of the cab to this customer. But when I'm doing a real-time processing, then I'm coming to know that from that customer, that data is means like the taxis are in the same distance, correct? This taxi and this taxi are means like I will take as 1 kilometer, 1 kilometer, 1 kilometer, 1 kilometer, 1 kilometer, 1 kilometer. So like that, if I'm saying that, okay, I need to assign uh, this taxis to particular customer, but I know that all are in the same distance. So, so here I'm just trying to say like that, okay, I need some data so that I can take a proper decision which guy is the best guy, best suitable guy for this one. Okay, so that my customer will be happy. Customer will not be in the problem. So suppose I am coming to know like that the prior is per the prior history, this taxi driver, uh, this taxi driver having a bad reputation. Correct. So I will not assign this taxi to this customer. So now thing is like that I need to process real time, but I need 1 year prior history of that driver so that I can take a decision. Hello.
Actually, our voice बीच-बीच में break हो रहा है.
अच्छा अच्छा अच्छा. Give me.
So now it is okay.
So here what is like that I need to process the real time, but thing is like that I need some other information, at least 1 year prior history of that, of this all three drivers. Then only I can provide a real decision that which driver is best suitable for this candidate. Might be like this guy is bad guy, but if I am not seeing the prior history I am assigning to him, he will not be happy. He will be sad. Correct. So and it could be like multiple other decision. For an example, just I want to see that what is the 2 hours means like in past 2 hours how many trip this driver has been done. So for an example, this driver has been completed 4 trip just in 2 hours. Okay, this driver 8 he is complete, but this driver is still not having a single trip. So in this condition, it's better for me to assign this customer, means like assign this taxi to this customer, correct? So such kind of decisions, we need to have at least sliding window 2 hours data for this data sources, means like from this means like customer details as well as the driver details, routes and all other information uh, is like 2 hours or 3 hours data must be available with me so that I can take a proper decision. So in the real-time processing, I know that this customer is in which location and which taxi is near to him, where he is going, multiple other things. This is coming in the real time. Just I need to assign. So here what I can do, I will just, this decision maker, this decision maker will just pull a data from my this layer, below layer basically. Okay, so that he can take a proper decision. So this is called the Lambda architecture, where like you are doing a real-time processing but based on few other big data concepts, like having a 2 hours batch concept. Basically it is kind of a batch view. So I will just say like that this guy is providing a batch view. Batch view in the sense like might be 10 hours 10 minutes data. Okay, or like, yeah, that batch could have be the window based, means like time based window or the size based window, and then this guy can take a proper decision that okay, yes, now I'm correct that I need to assign to this guy or something like that. So yeah, assigning to this driver. This is the Lambda architecture. Okay, Kappa we will discuss later, but I was just trying to say like that in our use case scenario, it was trying to say like that you need to process the real time, but you need to also save the data in cold storage. So whenever we are talking about the cold storage, it means we are saving the means like it should be cost optimized. It should not be like that we are keeping in the warm storage and we are paying good amount of money. It will become expensive for me. So it's better to use the cold storage. So we will discuss later about the cold storage, but this use case is clear or not now?
This use case is clear. The diagram of the purchase, if you just.
Sorry?
The diagram.
This diagram?
Yeah.
Yeah.
Real-time processing. So यहाँ पे decision is asking because it is real-time processing. It doesn't hold any data.
Yeah, this
so
will not hold any data.
It is using some batch view. Batch view means what? So you're talking about the batch job or?
No. Batch view in the sense like that. I just want to take a decision based on 10 minutes data of this 3 users. Just I want to know that 10 minutes data, that how many trips he completed, because 10 minutes before might be he was idle or he was completing a trip. So I know in the batch view just 10 minutes before he completed the trip. So it's good that we should not assign to him, assign to other guy who did not have any single trip in past 10 minutes or past 30 minutes. So batch view is basically it is just doing a processing on the 10 minutes window batch size data. So batch is basically it could be time based window or it could be the record based window. Suppose I want to check that 1000 records of that uh, driver 1, 10,000 of driver 2, 10,000 of driver 3. I want to take any kind of decision. So I will just ask to batch view, give me the batch of 1000 records for particular driver, or I will say like that, okay, give me the 10 minutes records of this taxi driver.
Okay, got it. And the down data is basically we are keeping the database for future processing and using the Basically, big data. Okay, basically, we are just doing
Yes,
multiple
here
sources.
just I was trying to say like that it is big data concept in the sense like I'm just means for an example daily basis, on the daily basis this data source is providing you the data. So this is like the data like trivial data we can say, but it will be useful for me for the further purpose. For an example, data source having a lot of logs and logs has been pushed to the cloud in the interval of 24 hours. So this 24 hours data, I need just the big data concept to process this data and keep it into the somewhere so that I can utilize it later on to take any kind of decision. Correct. So store it is not like that it is only send you the real-time data, but other NFR related data is also required for you, which can be archived to the cloud uh, in the bigger interval like 12 hours, 24 hours, something like that. Because real time most of the times it is expensive. So suppose you are keep on sending the logs in the real time, definitely it will be expensive. But if suppose I am zipping 24 hours data and I'm just sending it to the cloud, okay, you can use it, you can process it later, but at least right now just ingest the data. So I will just say like that, okay, let the data accumulated for 1 week and I will just process, I will run my big data job in the weekends. So Lambda is trying to say like that such kind of data, why you want, so earlier how it was like that, you are having a one pipeline for that real time, one pipeline for big data. So it is saying that why you are doing all those things, just having the one consumer which is taking care about sending the data to real time processing and the big data concept as well. Correct.
Got it. So Lambda, we have some multiple areas, right? Lambda, this one is the ETL concept, then another is our
No,
especially
yeah, but
Java में जो है, and then AWS is having its own Lambda.
that
So
yeah, don't get confused with that AWS Lambda word. Basically, it is a Lambda architecture. Basically,
this
nothing
is
else.
Lambda architecture.
Yeah,
Okay.
yeah, yeah. So yeah, it is nothing related to the AWS or Azure or cloud or something. It could be applied for on-prem to on-prem, on-prem to cloud, or cloud to cloud. It could be anything, but it is just an architecture. That's all. So okay, so. Uh, Now we will go to that. So use case is clear. Is there any question on the use case?
No, no, no.
Okay. So
Right.
there are some assumption. Assumption is like that store computes do not have the large headroom and not suitable to run the high resource intensive software. So this is the major point where like we need to think that we cannot use very CPU intensive uh, tools or CPU intensive services or CPU intensive servers. When I'm saying that servers, it like we are having that multiple web server, app servers like take it as a Tomcat, Jersey or anything. So when you are designing, then you must have to be clear about that. Okay, I should not use a very heavy CPU intensive services. Basically, you should not take the
So
consider.
this
Yeah.
requirement given by a technical guy or a business guy?
This will come from the business. Basically, this is the business guy is saying that business guy is connecting with, so business guy is just going to that discussing with their means like online stores and getting the business. Okay, then they are getting a requirement, but they are also collecting the requirement about that what is the condition of online stores. So he is aware that okay, they does not
But
have the
this word headroom
yeah large
is
headroom.
a technical word or is a business word?
It's generally means like it is a mixed kind of word. It's business as well as the technical, but like the business guy must have to be aware. So for an example, in the online store, uh, cloud business guy is talking to the one of the guy from the online store, and he's saying that yeah, means like we don't have that kind of big large headroom because my IT team just informed me. So online store business guy is also in the sync with that yeah business store IT team, and yeah means like cloud business guy is also aware that okay, I am having the good amount of compute power, So he's just checking and he's getting the information from ID team and updating that, okay, not having the large headroom. Because whoever is designing as technical architect, he cannot go to each stores and cannot ask what is your headroom size. Instead, he will just ask to product business guy basically. Correct.
Mm.
So yeah, means like he is aware that data schema is large, is seen in retail industries domain, but consistent across all the store. So when we say like the data schema is large, means like it's not like few number of columns. It's like more.
Data schema is large as seen in the retail industry
Yeah.
domain, but consistent across all the stores.
Yeah. So
Okay.
basically means like whatever the data I'm getting from the S1, having nearly same kind of schema for S2 and S2. So I know that data nature is common because
Mm.
schema across all the stores are common.
Okay.
Data is unique in a store but can be non-unique across. Okay, means like it might be possible that S1 is sending you that same kind of data as S2. That could be possible, but can be like unique as well. So yeah, means like it's all about that the uniqueness of the data. Each order
Yeah.
is processed in about 10 sequential steps before it reaches to terminal state. That I already explained earlier. Cloud-based search APIs need to be always available. So here, when we say like that always available means we are talking about the HA. So in the cloud world, HA is representing the high availability
Mm.
with the response time at the 95th percentile of under 500 milliseconds. So this is the concept of measuring the latency. Latency is like you are sending a request, but you are waiting for a response. Then you are measuring in the numeric way. So this one we will discuss later about this concept, like how we measure the latency. Data on cloud data store needs to be as near real time as possible. So that we already discussed, like near real time, hard, soft, and all those things. No data loss is allowed. So yeah, this is the major point. This is the major point where they are talking about that the data loss. Then they are talking about that the latency.
HA.
Yeah. Then they are talking about again that speed. Then they are talking about that you should not use multiple steps. Okay, to provide the data, means like to provide the vision, to provide the analytics diagram, or to provide the dashboard. And yeah, this is the uniqueness and non-uniqueness of the data. This is about that the model, data model basically. And yeah, this is about the infrastructure. So most of the things, if you will see, you have got it here, like high availability, low latency, data nature kind of things. Okay, so most of the things are available here. So these are called as a constant basically. So if one of the constant is fail, your design is completely fail.
Mm.
Now here is the load characteristics.
5,000 stores.
Yeah, so here they are providing more detail about the we can say like that how much amount of data is being generated and from how many sources it is being generated. So here you can see that the system need to support 5,000 stores in one geography.
Mm.
Here, if I'm talking about the one geography, 5,000 stores, so I need to make sure like that I should be able to support for the next geography as well, and that may contain 5,000 stores. So it could be multiple geography. It could be not like that only one geography, but right now it is saying that the system needs to be support 5,000 stores in one geography. In that condition, I'm just trying to say that stores are available into the multiple geography, and each geography can have like 5,000 stores or less than upper than that. Okay. Yeah. So now here it is like that 2 million orders across or processed across all stores per day. So each day it is being generated 2 million. So now if I will calculate 2 million multiplied by 5,000, so that many orders are being generated per day, and that we need, that our system must have to be support to process all this data in the near real time. Data need to be written in the cloud storage for the, so this one is the data retention policy. This we can discuss later, that how we can retain the data for 1 year into the warm and 7 years for the cold, and after that how we can retire the data. Retire the data in the sense we can drop the data. So it is saying that do a high level design, okay, and then your design must have to be answer all these questions, okay. So I hope like everything is clear here.
That load characteristics, the third and fourth point, they are all the same. Data needs to be retained in the cloud storage for a period of at least 1 year. Data needs to be retained in the cloud storage. So basically, it is telling at least basically 1 to 7 years. Maximum is 7, minimum is 1.
No. It's saying that so that is the concept of warm and cold. So if we will talk about in the warm and cold prospect, so it's like very simple. There is a noise. Hello.
Yeah, I can hear you.
Okay. No, I was just saying like that there is a noise, background noise is coming. So yeah, so there is a concept of warm. So not, don't take it as a data. I will just take it as a storage, and I will talk about that the cold.
So warm is basically the storage point of the not sure. Basically on the EC2 or anything we are telling about, it will be ready, so that immediately you can launch it. Basically it will be properly having its own images, having all the setups and everything. So storage point of view, maybe that we are talking sometimes not database also warm and cold.
Yeah, exactly right. Same thing.
Database.
Yeah.
Right?
Yeah. So
that let's say the scalability or scaling is scale out is happening. So if your the database is ready, immediately it can scale out.
yeah.
So you don't have to start the server and then do the setup configuration and prepare the data. That will take round of time. So that's why it will be in the warm mode.
Yeah.
So that immediately it can within a few seconds time it can be launched.
Exactly right. Exactly right. So here is difference is only that ki suppose means like your data is here for 1 year in the warm storage. So 1 year you used it, but after that you are just transferring all this data, migrating all this data to cold storage. That's all.
Oh, so here cold will become almost like archive database.
Yeah, exactly right. Yeah.
Become glacier or something.
Yes.
Warm is the basically the high frequently used.
Yes, exactly right. So it is so use case is saying that okay, keep this data into the warm layer so that anytime I can I can access without any latency. But after that I don't want to pay the money for warm storage, so I want to store into the cold. Okay, and then actually there is a noise is coming. Okay, yeah. So I was just trying to say that data must be available into the cold storage so that I no need to pay the money for the warm storage, and anytime I can pull the data from cloud cold storage and I can use it. So it's all about that the cost saving uh, concept, and I'm not losing any data. Hello.
Yeah. Hello.
Yeah, it's fine. So yeah, just I'm going ahead. So is there any question? If not, then we can start the designing part. Yeah. I'm starting the designing part. Okay. So if I'm just taking data sources, so these are the data source, and this data source is basically, so what I'm exactly doing, I'm just following this architecture in such a way that there is a lot of background noise actually.
For me, there is no background. So, are you able to hear from me?
Yeah, a lot of background noise.
Oh, okay. Then
Yeah, and now you're on mute. Can you try again to unmute?
is it okay?
Background noise is coming basically.
Okay. I put it in the speaker. So I will put the headphone.
Hmm.
Okay. Continue.
Okay, yeah. So
Is it better?
yeah, it's still too much background noise is coming.
Background noise. Hello, sir.
Okay. So now what is there, like we are having the online store. So these are my online is like these are my stores, and here I'm just saying that S1, S2, S3. So take the first store and we can just scale it later. So if I'm just taking the one store, then what exactly I need? I know that this store is means like already having system which is doing the transaction. Correct. So these are the users who are just doing a transaction for particular uh, store from a particular store. They are doing a transaction, and I know that this data is going somewhere. So I will take a system here, like this one. Okay, and this transaction is being happened. I'm just talking about the single store here, and data is coming here. It might be the one database, it might be two database. Don't think about it as a database, just think like that. Data is being saved somewhere. Correct. That is the reason the transaction is happening. Correct. Now, just we are assuming, means like is a technical architect or means like is a designer, I'm just assuming that already data is available uh, to pull means like this if I'm talking about this S1 on this store, then I'm assuming like that already this functionality is working, because they have already mentioned this word like do not have the large headroom and not suitable to run the high resource intensive software. It means they are having a compute power, still having the compute power, but not large enough. But at least I can assume that the transaction is being saved somewhere uh, in the database or any kind of file store or anything. So what is my next job? My next job is like that I need to pull a data from here. It's not, don't think it is a database. I'm just trying to say like that it is a data source.
Correct.
Data source in this in the means like it might be possible that a REST call, or it might be like that the transaction happened and I'm saying that okay, push data to me. I'm just adding one more software. I'm just adding one more services like pull mechanism or push mechanism. It could be anything. So here I'm being flexible because it is a gray area for me. Should I get the data from database or should I get the data from particular API or anything? So just I'm assuming like that this is my data store, and I'm assuming that I can pull the data from here. Correct.
Okay, so this data source is this is the data which is residing in store one, right?
Yes, store one. So this is the complete concept for the store one. But here I'm not saying a single word that okay, I will pull it from here. I'm just saying like that this is a data store. It could be anything. It could be API. It could be flat file. It could be database as well. Correct.
Yeah. So basically, in the next step. This will be the my source of data.
Exactly right. Yeah. So it's all about that. Now, how to plumb the data, from where to plumb the data. So from where we are having the assumption, and now from how to plumb the data is the main question. So I'm still in the store one. So till here, I will just say like that. It's not my part, it's the existing part. Existing part means it's already there. Now my part begins from here, from the right hand side. But yes, whatever I am doing in that S1 store only. Now I need something which can pull the data from here in such a way like that uh, it should not create any kind of latency. It should not create any kind of backlog. So backlog in the sense this user came here, I got a transaction detail, but it is taking a longer time to process the data. And meanwhile, we got the one more transaction. Now problem is that this is in the pipeline. Correct. So that should not be there. So here, this layer, I need to inform that what kind of service I am going to use it. I cannot just say like that, this is my consumer and I cannot go ahead. So I cannot say like that, this is my consumer, this is my processor, this is my uploader to cloud. Yeah, that is true. Means like extremely high level, if you will see, I can say that is fine. I will just say like that, this is my consumer. Correct. This is my processor. Correct. And this is my uploader. Uploader in the sense who is uploading to the cloud. Yeah, it looks fine. It looks fine that okay, high level, but it is not giving any insight. It is like common thing. Everybody knows about that. Okay, this is your consumer, this is your processor, this is your uploader. That I know. That is written into the requirement. You are projecting programmatically. Correct. Here thing is like that what I need to use for consumer, what I need to use for processor, what I need to use for uploader. So here I don't have any dependency on processor to take a decision what will be my consumer. To take a decision what will be my consumer, I'm not dependent upon the processor because I know that my consumer should not create any backlog. This is my restriction. This is my constraint. It should consume in such a way like that in the millisecond you are clearing the message. Means like this transaction 1 came here, this T2 one came here. You just process it in the millisecond. You cannot say like that it should be in second because real time session is saying that I am in second. Means like complete pipeline needs to be done in the second. So definitely when you are consuming the data, you should talk about that, the consuming into the real time. Correct. And it should be in the millisecond. That is the reason. Means like if you will sum all the steps, then only you will reach in a second. Correct. Otherwise it will reach to minute or it will reach to the hours. So now here we need to provide the right design with the right service, what we are going to use it. Okay. So here I cannot use any kind of AWS service, definitely because I am in the on-prem. If I am going in the on-prem, then I am having the multiple services available uh, which can help me a lot for pull the data from here. But this data must be in the real time. It should not be like that, means like data came here, then I am checking which data I need to pull. Okay, because that taking a decision could take a longer time. So that is the reason there are the multiple proven API which are taking care about all this requirement. So any kind of transactional data is coming in the real time, they can consume it. So I'm just talking about the consuming. I'm not talking about that what I need to do with that data. I just need to pull it from here immediately. So
because decision is not made, it is just consolidation of the data.
Yeah, exactly right. Exactly right. So even means like in this time, I'm not thinking about the consolidation. I'm just thinking about I need to pull the data. That's all. That is my primary goal. I should not spend the time to pull the data to take a decision in which data source I need to go, what I need to do. I cannot run the cron job here continuously. It is not possible for me. So I need a listener which is associated with the data source in such a way like that immediately data is coming, I should not wait for the notification. I should wait for that data itself. So it should not be a round and miss like making a request response call. It will be just like the response call, because the listener saying that I have subscribed to you, you just push me the message whenever it is coming. Don't notify that, okay, I got a message, do you want or not? Forget about it. Just give me the data. Okay. So means like we can say like a database having a trigger is same kind of mechanism. Whenever the table is being updated, deleted, or having a new record, it is being triggered, and then you can take a decision. So just means like it's similar. There are the multiple utilities are available which can help you here to consume the data, and one of them is called as a Kafka Connect. So uh, Kafka Connect is similar kind of means like Kafka Connect is helping you to fulfill all this requirement. Yeah, there are the multiple, but right now means like uh, we know that Kafka Connect is better. Then why we should think about the others? Okay, okay,
Yeah.
okay. So now I will just okay. Let me check it somewhere. Okay, give me 1 minute. Yeah. So here I'm having a Kafka Connect which can uh, which will work for me as per the requirement. Requirement says like that you should have all the data in the real time, means like in the millisecond, and yeah, there should not it should not create any kind of backlog, because we need to do a heavy lifting later on. So now this Kafka Connect having multiple messages, correct? But Kafka Connect is saying that, okay, I can get the message, but I need to keep it somewhere. I need to write it somewhere. This is my first job. Because if suppose I am taking one message from here and I am processing it, then means like uh, I am spending more time for a single message. So if suppose this is the message one, this is the message one, and there is a one more message two, and yeah, there is so on like that, message three. So here I will try to do a loose couple architecture. So means like this guy is my consumer, like mentioned as a Kafka Connect, and I am taking M1 and I am doing a processing. I'm doing a processing in the sense I am taking some business decision on that particular message. So, and then I will write it to the something in the processor or somewhere, means like, or might be a storage, something like that. Okay. So, okay. So this is my is yeah, processor are take something like I'm writing the message here. Okay. Now if suppose this guy is taking 2 second for an example, 2 second, or yeah, just take a 2 second right now. This guy is taking 2 second to consume this message and to write into the storage. Okay, but taking some business process, taking time for a business processing, taking some decision, or it is just checking that, okay, message is valid or not valid, or having the time stamp or not, or multiple other things if it is doing, then definitely it will, this is taking a long, this is taking a 2 second, then this guy just arrived within a 1 second, then definitely there will be a delay. It needs to wait for that 1 second, correct? So what I need, I need one more layer here. Okay, one more layer here, and I will just say like that, okay, I'm not doing anything. This guy is saying that I'm not doing anything. I'm just getting it. I'm just pumping it here to you. I'm just giving it to you. Whatever you want to do it. I don't care. And this guy is saying that, okay, no need to worry. I will take care about everything. So here, this guy is helpful for not creating any kind of backlog and consuming all the messages on time, because it is saving the time. Processing logic has been removed and has been assigned to other guy. Now there is one more layer I can create, that okay, if this will become a cloud, then I will say like that, okay, this guy should not upload, and instead I will assign the task to the uploader. Okay, so that is the reason we are having the two pyramid here. And as well as, if I am designing this component in such a way like that, it is best suitable for consuming the messages, then it will become independent component, and I can use in other design as well, in other use case as well, because processing logic has been decoupled from here. Correct. So only it is the consumer. If suppose I am mixing both processing and consumer, then definitely for other use case, processing logic can be different. Okay, so in that condition, I cannot use it. So that is the reason here I'm just trying to say that, okay, I'm having a Kafka Connect, and Kafka Connect having a task to just read the message and push it to somewhere. So where we should push it. So we need to push it in such a way that message can persist for a particular time interval, so the data, so there is one more point here about the data loss. So there should not be no data loss is allowed. Data loss. So here I want to write somewhere so that I should not lose the data. Okay, and it should be highly available. Correct. So if suppose I will keep on writing into a database here, from here to here. So right now just I am removing this part because processing is a kind of concept which is like processing the message, but real time just I will pass it directly to processor, then might be processor component is down, then you will start losing the data. Where it will write? Kafka Connect, where it will write? Your processor is down currently. Correct. So my Java API, my Python API, whatever I was taking a message and I was processing it, I'm down here. Okay, then definitely I will lose my message. So I cannot directly send to my API. Instead, I will try to write into database. But if I am writing to a database, correct, then situation is similar. You are ending with the same situation. Only thing is like that earlier you had the 3 data source, but now you are having a single data source. But situation is same. Correct. Correct. Then again you need a Kafka Connect here. Then you are ending up with the same situation. So I cannot use the database here. So what I can use that, suppose. Sorry, I lost you. Why database cannot be used? Because database will store the data. Let's say the processor is down, you will be having the persistence layer. Yeah, persistence layer. Once the processor is off, it will go and read it from the database and then do it. So in this situation, processor has to connect to this guy, or it needs to go to, means like again we need a Kafka Connect, and then we can provide to the processor, something like that. So it's like we are multiple times. Yeah, we are spending more and more time just to ensure that no data loss. So this is not the right architecture, where like we are taking a data from multiple database and writing into the single database, and then again I'm using the same kind of concept where I'm just listening the real data time, because I know Kafka Connect is better, and then sending it to persistence. So again here you will see, if suppose processor is down, then again you will start losing the data. Okay. Correct. And Kafka is having that messages also can be retained for a longer period of time, right? 1 year or so, at TTL. No. I will jump on that point. So basically here, I should not use that database. There is one more reason not using the database is that it's expensive. Expensive in the sense like it takes more time. If you are keep on writing to the database, reading and writing takes more time. So it's not good to have the database in one more layer in between. So here there's the best thing is that we use queuing mechanism here. So that is called as a queuing mechanism, where like we can add a queue there, and queue having a mechanism that if it will persist the data, It will write with the higher efficiency and as well as...
I actually thinking Kafka Connect is the queue.
No, 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 no,
Because
no, no.
Kafka is...
No, but if suppose I am using a queue here, then how it will get pushed to my queue? That will become difficult for me, na? Means like,
okay. So
might
then
be...
data source has to push it.
Yeah, and that architecture means like, I don't know who are going to send me the data. So I need a layer in such a way like that I can at least pull the data from any kind of data source, any kind of database. But Kafka, if you will let it Kafka there, then you need to write a component which will send data to your Kafka topics. Correct. Someone has to send in the Kafka topic.
Maybe I lost. Kafka I understood. Kafka Connect, how it is different?
So okay, so give me 1 minute. So let me take the Kafka. Okay. Okay. Suppose I am having a Kafka here and I am removing the Kafka Connect. So this data needs to go in Kafka? Correct. Correct. But how it will go?
So I have to write in the source. There will be some program or something I have to write which
Yeah.
will push it to Kafka.
Yeah. But
Kafka topic.
Kafka topic. So to send the data in Kafka topic, you need to write your own code, and might be that is not scalable. That is not means like everything you need to manage and you need to maintain. Correct. This code, if suppose I am just taking one code which is your Java API or your like Python API or anything. So this many things you need to write in your code, okay, and you need to just make sure that you are like providing the high availability to this guy, okay. And if suppose there is a new data sources coming like might be MySQL or something, again you are changing your code, deploying your code, multiple things you need to do that. So instead we are saying that you cannot achieve that much high availability and multiple other things, fault tolerance, that is already there in the Kafka Connect. So use the Kafka Connect because it is meant for it and no need to write your own code.
So how does Kafka Connect work? Okay, I understood Kafka.
Yeah,
Connect.
so again that is the Kafka Connect with the node sharding and other things and
okay, so Kafka Connect directly reads from the data source.
Correct.
Okay. So the arrow has to be then ulta, right? From Kafka Connect to data source.
Yeah, you can just...
It's not a push, it's a pull.
Yeah, it's a pull basically. That is true. But I'm just trying to show here that the data flow.
Okay, data flow wise it is correct. Left to right it is going.
Yeah.
But the architecture wise, Kafka Connect is having its own technology or the listening this one, so that as soon as the data arises, it is going to pull the delta and then...
Yeah. So Kafka Connect having the multiple like bulk, that incremental plus timestamps. There are the multiple concept. Kafka Connect having ability, it can pull first time all the data from your database. It can send it to the Kafka and then whatever the incremental data is coming, it will start taking the incremental. Or if you just want to deploy today and you want to say like that, forget about the history, I just need the data from today only. So you can just say like that incremental, or you can say like timestamp and boom. So otherwise you need to write your own API and that will be more painful.
Got it.
So Kafka Connect having multiple advantages. So here the main role is that, okay, now the picture is being more clear that what exactly we are using, why we are using, is it fulfilling all the requirement of that use case or not. So yes, I am maintaining the high availability for my service which is Kafka Connect is giving, and it is not creating any kind of backlog and having the high latency. I mean, it's like there is no latency basically. And after that, I'm using Kafka here because I know that this is the proven one. So Kafka is providing means like
Kafka is having its own queue mechanism and also and then TTL and all. So
yeah.
So okay. So Kafka Connect is a connector. Maybe I somehow missed it.
Yeah. So what about the Kafka? Kafka I'm using because I know that I can process the million requests without having much latency, and I can make sure like that I'm taking about the fault tolerance, I'm taking about that high speed, high performance, high availability, and no data loss. No data loss in the sense like if I will just talk about that, the no data loss, then it will be, give me 1 minute. Yeah, till here it is clear or not?
Yeah, it is very much clear.
Yeah, I will talk about, I will talk more about that fault tolerance things and more about our Kafka part. That why we are using the Kafka here and other things. Okay. Meanwhile, let me, give me 1 minute. So here I was just trying to explain like that the Kafka part. So Kafka part is being taken care by the multiple strategy, like how you are making it sure that there is no data loss. That is called as a replication factor. So here I was just trying to explain that the concept of Kafka is very simple. Like it works on the multiple nodes, so you can deploy into multiple machines, and that will be called as a single cluster. So one cluster can have the multiple node, and each node having the multiple broker. Okay, inside that broker you are having a partition, and these partitions are utilized to store the data. So the concept is very simple. Like if suppose I am producer, I am sending data in partition 1, then what exactly is happening, I am making it sure that there should not be any data loss. So what I will do, I will make a replication factor. So whenever any kind of data is coming, I will say like that, okay, store the data in here as well.
So it is basically this, whatever is, it will keep in the same node, means same machine.
Yeah.
Then replication is also happening across the machine as well.
So it's like that there are the multiple strategy like how the replication factor needs to be happen. So one is like that the rake concept, then
This is RAG concept, right?
yeah, disaster recovery comes in the picture, but there it should not be like that your high availability should not get compromised. So but that is also true that disaster recovery should also get means like fulfilled. So it might be possible that if I am doing a replication, I am not doing on the same node, because it is not a good strategy. If the same node is going to down, just right now you can see like that I am doing a replication in the same node, but if this node is going down, then definitely data loss is there.
So this node 3 may whatever is happening, it is the RAG concept.
So yeah, basically means like I will go for one more node. I will go for that one more node, and I will
Node
say like,
here is a computer, or node here is we are talking about the data center name.
it's think about the one computer only, means like one
VM.
CPU, we can say like that.
One VM. Yes.
Yeah, one VM we can say like that. Yeah. So what I will do like that, I will just pass this guy. It's like it is a better strategy that okay, use the node. Sorry. Yeah. So I will just say like that there is a one more node one. So I will say like that this data needs to get copied in the partition of this. Yeah, in the same partition. So this is not a good strategy. And if I'm taking in a broader level, then I will say like that, okay, go for a node 3 as well. Correct. So that I am replicating the data in such a way that even though node 1 is down, even though node 2 is down, at least I should be having the data available into the node 3. So Kafka is just working the same way that producer sends a data here, but it is being replicated internally by Kafka master, or Kafka is designed in such a way like that it will take care that where I need to copy the data. Yes, that you need to mention sometime, because might be possible that okay, you are pretty sure that uh, I don't want to copy 3 times. I want to just keep the 2 copies. Then I don't need this one. Correct. So I will remove this part here. I will remove this part. I will remove this part here. So basically producer send the data into the partition 1. It get copied into partition 1, but in the different node. It might be possible that if someone is saying that, okay, I want to go for disaster recovery, then I will say like that, okay, this node 3 is residing into the different region or different account. Now I hope everything is clear.
So this node 3 is in different AZ.
Yeah, exactly right. Exactly right. So my all task is done here. I'm taking about the disaster recovery. I'm taking about the fault tolerance. I'm taking about the data availability. I'm taking about the no data loss. So, but if suppose I am writing my own API, then definitely I need to achieve this much and it will take a very longer time. So Kafka is saying that I am there for you. Just you need to configure me in such a way like that you are achieving everything. That's all. So that is the reason I am using Kafka here.
Correct.
Okay, so this is the one more concept, like when you are using a producer. Producer is nothing but here producer is Kafka Connect for us in this diagram, in this old diagram. Kafka Connect is my producer. Okay, and even in producer you can mention that in which partition my data should go, what will be my replication factor, what will be my offset, and what will be my key. So multiple things you can define when you are sending a data. But if suppose you do not have Kafka Connect, then you need to write your own code in such a way like that to handle all these things, which is extremely difficult. Means like it will take a hell lot of time to do that. Correct. Um, because producer one is saying that this data is coming from data source one, and this is only the audit data. This is coming from the data source, the account data. This is the data is coming from that items inventory data. Okay, inventory data, and this is the transactional data, and this is the audit data, or GST or something like that. Okay, but I need to keep this into the different topic. Correct. So during the time of writing into the Kafka, this Kafka Connect is utilizing all this configuration and saying that Kafka, you are having three topics. Kafka saying that yes, already as per your previous requirement I created and it is ready with me. Okay, let me know the Kafka topic name so that I can post the data to the relevant topics. So Kafka works on the based on the topics, and these topics are being written into the partition are nothing like that. It is the means like kind of how to say like that, it's kind of an infrastructure design where like it is a dedicated portion where logically it is being divided that whenever the consumer is coming. So for an example, if I am having a consumer, this consumer, then it will say like that, okay, Kafka knows because it is logically named it partition 1, and consumer is saying that, okay, can I have the message for the kind of audit report, audit data only. So Kafka is saying that, okay, you know the topic name. So yeah, topic name is audit. So yes, it is in the partition 1, just you listen it. So this one is going here. So after that, it is saying that, okay, man, I'm not able to listen this partition 1. Seems like that there is a network issue. Okay, no problem. Listen from node 1. Saying that node 1 is also down, you no need to worry. I'm redirecting it to the node 3. So it is happening in such a way, it is extremely fast that user will never come to know like that, okay, node 1 is down, node 2 is down, both are down. No need to worry about anything. So here, Kafka provide all those things, so we no need to worry about anything. Uh, yes, so this is the Kafka things where we are having the topic, and topics are associated, means like topics are being used by the Kafka Connect to push the message. So we have means like achieved all the requirement of that use case. Now we need to send this data to the cloud. Correct. So I will remove the processing. Okay, I will take it as a processing part. So now what will happen when we are having the Kafka here, then data is being resided into my partition, but someone has to come there which we need, which will listen your message and process this data to cloud or anywhere. Means like Kafka is saying that I'm not doing anything for you. I'm just saying that, okay, you just I'm just storing in such a way like that in a highly fashion manner that, okay, data will not lose. But it is your responsibility to listen the data. But here thing is like that, I need to join the data. I need to do some kind of weightlifting here. Weightlifting in the sense, let's suppose there is a join, a relationship is there between the transaction data and then customer data or something. So I need to do a join on that particular data. So how I can do that? I need to pull the message from here. I need to write my own logic and I need to make it sure that, okay, my component should never go down. So there is the multiple requirement which we cannot achieve. Correct. Means like we will be end up with the same situation like why we use the Kafka Connect, why we use the Kafka here. Now we know that the message has been stored in a particular topic, but we need to join that. We need to do the aggregation. We need to do the sum. We need to some little bit kind of processing on that data. How I can do that? Okay. So for that, I can just write a Java utility. I can deploy into my Tomcat and I will provide it here. Correct. But again, if suppose my Tomcat is being down, there is JVM out of memory is there, then it is in the on-prem. How I will send the notification, then who will come online, who will fix all these issues? Correct. So this is again a problem. Then you will use our load balancer. We will say like that, okay, suppose this node is down, then go for these things. There are multiple issues. So what exactly we do? We look for some other utility and Kafka has provided the utility. It is called as a Kafka stream. So I will just take I will just take an icon of the Kafka stream and I will say like, okay, use the Kafka stream here because it is useful for joining the topics and it can do much more kind of aggregation kind of concept. So I will say both side arrow because it is taking, it is processing. Okay. It is processing and again sending into the Kafka. So my aggregation, sorry, my aggregation, my join, give me 1 minute. Yeah, my aggregation, my join, my multiple requirement has been fulfilled by the Kafka stream. So it's basically one more thing. It is a distributed processing. So suppose your Kafka having the million number of messages. Still, Kafka stream is saying that okay, you no need to worry. I do the distributed processing so that it will be happen very quickly. There is the no downtime rolling deployment in the sense if suppose there is a patch upgrade you need to do, you need to deploy your code, you have to change the logic. You no need to worry about the downtime and other things. Then other thing is like that the best thing is like that it process the message in millisecond latency. Okay, it does the join and aggregations. These are the main things which we are giving it to the Kafka stream so that okay, I will just write my business logic, but I will now need to be worry about how the distributed processing is happening and other part like the why it is fast and other things. So here it is clear like I means like I'm done by delegating the task. The first task is like that, okay, dump all the message here. Kafka is saying that, okay, no need to worry. I will write in my persistent store. Then this guy is saying that no need to worry about the data loss or the distributed processing or the performance or the business logic. I will do your business logic here. So these three tasks are delegated tasks and distributed tasks, and I'm fulfilling all the requirement of that use case.
So Kafka Connect is basically integration. That we are very clear.
Yes,
Kafka
yes.
streaming is having actually the business logic.
Exactly right. And this business logic
Kafka
we are writing.
is basically mostly feel because this to segregate their definition or the meaning. So Kafka is only the layer where we are just holding the data for consumption purpose.
Exactly right. That's all. And that is
So,
yeah.
So holding the data is basically holding the source data from Kafka Connect, but in the meantime, Stream is also working on those data and pushing it to another, let's say, topic.
Exactly right. Yeah.
Okay.
Now the thing is like that I'm having the pre-processed data. I will say like that pre-processed data because I did the join, I did the aggregation. So pre-processed data is here in the another topic. Now I want to send it to the cloud. This is the task only I am having. Correct. Now I don't have any other task.
Yeah.
Just I'm having the data in my topic. I just need to send it to the cloud. So now here there is one more thing. What kind of, so there are the few things like being a, whenever I'm designing, I must have to design in such a way like that it should be cloud agnostic, it should be language agnostic. So here you will see I'm the language agnostic. I can write into that PHP, sorry, I mean to say Java. I can have that Scala or other language here. Okay, in the Kafka stream, I can write my own code. So here I'm not saying like that I'm like saying that, okay, you do the Java coding only. I'm not saying, I'm saying that, okay, these all are that agnostic to the language. Okay. Now here I want a service, so it is cloud is like AWS cloud, or it could be Azure cloud, or it could be anything. Just I need to upload my data. So any kind of service if you are using, it could be like AWS IoT or Azure IoT or like any kind of service. I just need a connector here. So it is completely decoupled. Correct. It is completely decoupled from the Kafka. So I can replace this guy from anything. Today I am using the AWS. Tomorrow if I am using the Azure, I can just change this guy. So this guy is my connector, but I am choosing a connector in such a way like that which is the well tested, which is provided by the AWS or Azure, and which is not having any kind of issues instead of reinventing the wheel. So I'm saying that,
Yeah.
okay, here might be I'm just coupling with my cloud provider, but another way I'm saying that, okay, if suppose cloud provider is being changed, okay, change me.
Okay. So Prashant, the previous, if you go to the page on 6, or not that, not that. That is Kafka concept. That is the one. Next, previous one. Previous one.
This one, this
No.
one.
Yes.
Yeah.
No, not that. Okay. Okay. Go there. Oh, okay, okay. I think we replaced the same diagram. Okay, so then go to that 7, sorry. On name 7. On name 7. Whatever
Okay.
you are working.
Okay. Sorry.
Okay,
Yeah.
so we initially put, after the left hand side, we put something called consumer, then processor, and then uploader.
Yeah.
So consumer is basically, we are talking about the connect, which is the integrator.
Yeah.
Then the processing part we told is basically nothing but Kafka and Kafka stream.
Yeah.
Okay. Now uploader is basically the connector which will upload to the cloud.
Yeah. So
Okay.
here I can say Kafka Cloud Connect. Correct. And another word I will just say like that. This one is my uploader. Which I need to just upload the data basically. But here what I'm trying to say like that, here don't be much, you should not be agnostic too much here. The reason is that if you want to become too much agnostic and you will say like that, okay, if suppose cloud is being changed from AWS to Azure, then who is going to deploy again one more connector there? That is the one more sentence. Basically, here it is debatable. So like here I will say like that, okay, it doesn't mean like that if it is being changed, just keeping in that mind, if I am being agnostic to the cloud and on-prem, then definitely I need such a connector which is well tested and can upload the data to any kind of cloud. And that is called the reinventing the wheel. What I should do, why I should do all these things. Just being the agnostic doesn't matter like I'm ending up with the multiple situation. Because AWS is saying that, okay, I am having one service that is XYZ, or AWS, take the AWS IoT, okay, AWS IoT, and I am giving you connector that is the AWS IoT connector with Kafka. But why AWS will give you connector for Azure IoT? It will not give you. So you should not write your own connector which will support to Azure, which will support to Google Cloud, which will support to AWS Cloud. No, that is the wrong approach. So here I am just trying to say like that, okay, in front, I know that If it is a AWS, then use the AWS connector. If it is Azure, then use the Azure connector. Got it. Yeah. So basically, yeah, means like it means people can debate on that, but yeah, means like depends upon technicality to technicality. But I believe on this concept that okay, if it is a proven one, then don't become too much agnostic. So here now I am having a Kafka Cloud connector, and it is nothing but uploading to the cloud. So here my first part is done, and yeah, secure and security we can talk about HTTPS and multiple other things, but this is just the cloud. So this design is ready. So this is the first part. Now if I will just copy and I will just paste it here, so it will become sorry. Yeah, so if I'm copying and I'm just pasting it here, so I will just select that okay, I'm there as a S2 guy. Correct. This is the second store. There is one more that will be third store. Correct. So right now I am saying that a store does not have good infrastructure and very less compute power. So I'm just saying that okay, Kafka is designed in such a way like that you can deploy into the low infrastructure. Yes, configuration you need to update. You should not have the multiple replication factor, multiple nodes. Even the single node you can run your Kafka without much issues. Okay. Yeah. So now there is a one more thing comes in the picture, and that one is like that deployment architecture. So everything you can do it in the Kubernetes. So Kubernetes is used where like you need to deploy Kafka stream, you need to deploy Kafka Connect, you need to deploy Kafka. So everything you can deploy into the Kubernetes, because Kubernetes having its own advantage of like for an example, there is a node running is happening, so it is doing automatically. You don't need to worry about the node switching and other things. And auto scale, like Kafka streams, today you are having the 100 messages, tomorrow 1 million messages are being generated. Yes, it will auto scale your pods, because in the each pods Kafka stream is deployed. Then when that data load is over, automatically it will do the scale down.
So this Kafka stream and Kafka Connect, Kafka stream,
Yeah.
three things.
Yeah.
Kafka is a managed service, right?
No.
Managed service means okay, we are talking about the open source, means the third party.
Yeah.
From Kafka itself.
Yeah.
So let's say Kafka Connect, first one.
Mm-hmm.
It will be having its own cluster configuration.
Yes. Why not? Yeah.
So Kafka also will be having its own. Kafka stream also can have its own.
Yeah.
So you have to achieve that scale up on all the three areas. So you are telling that we can launch it as a pod or something using Kubernetes.
Yeah, exactly right. Yeah.
So whenever it is required, the Kafka Connect itself can scale up and scale down. Similarly, the Kafka and similarly the Kafka streaming.
Yeah, exactly right. So I will add the Kubernetes here. So yeah, so I can have a single cluster, I can have the multiple cluster. It depends upon me. For that Kubernetes means like where I'm deploying in my Kafka, where I'm in which cluster I'm deploying my Connect. So it depends upon me. If suppose there is a very less infrastructure, then definitely I will go with the single node concept. I can go with the single cluster concept. Yes, but I need to compromise with the other things like having high availability and fault tolerance part. So generally it is advisable to have the multi-cluster architecture, multi-node architecture. So here I have deployed into the three different cluster. Okay, I'm assuming that okay, I'm having good enough amount of the infrastructure. So I'm saying that cluster one having a Kafka Connect, where I'm saying that multiple nodes are spinned up. It is a distributed processing and parallel processing. So for an example, if suppose data source one, that upper one is producing 10,000 messages per second. This is the 20,000, this is the 30,000. So I'm saying that okay, I'm having three node which is parallelly running and keep on consuming this message and dumping it to the Kafka. Kafka is saying that you no need to worry, you are in the node 3, I am also in the node 3 or node 2. I'm providing you all the replication factor and topics and higher IO so that you can write in the faster way. Then Kafka is saying that, okay, no need to worry. I am also scaled up. Multiple pods are there, and now I can start processing your messages in the parallel processing and the distributed manner.
Got it.
So Kubernetes is saying that, okay, you guys no need to worry. If suppose you have to consume higher number of messages, I will scale up. I will create multiple pods for you, and you no need to worry when it is going down. When the requests are going down, I will scale it down. So you no need to worry about anything. So it is complete the delegation of the work. So Kubernetes is doing its own job for that, making it highly available your services, making it auto scalable so that if suppose higher number of messages are coming, it will auto scale. If it is not, then it will scale it down. And then Kafka is saying that, okay, no need to worry about anything. I will write, I will provide the persistency, I will provide the replication factor, and I am running on the top inside that Kubernetes. Kubernetes is doing its own job. That's all. So we are done. This is the complete. The first part is we have covered about what we need to do, why we need to do, how we need to do, how we need to deploy.
Kubernetes sometimes doesn't look like to be a little bit complex.
In the sense like a little bit complex in the sense like deployment part.
No, उसका जो image file, Docker file, then how are you going to keep its persistent storage? Too much of configuration. Sometimes a little bit complex, no?
Yeah, but it is not complex. The thing is like that you must have to be aware that, okay, how much replication factor is required. You must have to be aware that, okay, means like what is the available infrastructure is there. I cannot go with the multiple number of nodes if suppose I don't have that much infrastructure ready. So yes, means like that kind of configuration is required, but one-time configuration is helping you a lot because after that, it's like fire and forget. You no need to worry about that how internally it is being worked and how
Scaling up and down.
yeah, even that Kafka, how it is that copying to the partition, how it is internally handling the fault issues, like partition one is failed to write. So you no need to worry. You are not managing it. It will auto manage everything. Yeah, but the story is not end up here because use case is saying that how the user is getting notified if something is going wrong. It might be possible that something go wrong. So here like we provide them, use multiple other components like monitoring. uh, yeah so for an example, your business logic is being wrong somewhere or something is going wrong, okay, you need to monitor it. So again, we need to deploy the monitoring tool, tracing tool, auditing tool. Multiple other components will also come in the picture in the
So
real time scenario.
monitoring tools will come, then the also security part will come.
Security
Basically,
part will not be that much because it comes with the OS, because we do a patch even though it is in the Kubernetes in that particular VM, we do a patching. So that part we generally don't cover, but yes, application related things like in the application we are going with that monitoring how my application is working. But when we talk about the security part, then we just say like that, okay, we can go with the HTTPS protocol and yeah, means like PHI, PII, those things we need to think. But yeah, means like that is the next area which we are not discussing right now because it will come under the de-identification part, as well as that how we partition our VM so that wherever we are processing that should not express to the internet world, but de-identified data when I'm going to upload to the cloud, at that time I'm saying that, okay, it is exposed to the world. So yeah, it's being complicated, but that's true. Like it is a one-time setup. So now I will just say like that, okay, I'm just going with the one more cluster, or like in the Kubernetes, same Kubernetes, I'm saying that everything is being there in the Datadog. So basically Datadog is one more service which provide you that other details about that services information. So is the data dog, not the data log. Data dog. And then we are having
Instead
other.
of this, you don't use ELK kind of, or ELK is basically.
Yeah, you can use the ELK. You can use the Grafana as well here. Grafana.
Yeah.
Yeah. So there are the
Grafana means you have to put the agent then, right? Prometheus and all.
yeah, Prometheus will come in the picture. So here multiple other NFR related services will also come, but I was trying to highlight the main part.
The main part.
Yeah, like how your
That
data is being
this
traveled.
one, Datadog and Grafana and all, maybe we'll discuss in operational part.
Yeah, yeah, exactly
Because
right.
once your architecture is ready, then how are you going to operationalize and then maybe put some Lambda or something to trigger such services or maybe something. So that will be the operational challenge.
Yes, yes, exactly right. Yeah. And it's like that might be like we need to upload the logs as well. So there is a one more service that should be like totally decoupled service from here, which is just keep on uploading the logs in the interval of 12 hours or 24 hours, so that you can do the team can do the log analysis, and they will get a clear picture what is going happen into the S1. So if I will jump to our old architecture, that is the Lambda architecture, where I was trying to say like that it might be possible that I am uploading the logs here, and that log I have generated means like I created the view. I have mined the data in such a way from the log that okay, it is getting it is providing good amount of insight on that logs, so that I can provide some business conclusion which is going to help to take the decision. So that kind of architecture also useful here when I'm talking that okay, I want to upload my log to the cloud, and it will be useful later on. I don't know right now it is useful or not, but yes, it could be useful later on. So yeah,
Okay, so let's have a logical conclusion here.
yeah,
We are okay. Then maybe we'll deep dive. The next one will be our the other NFRs, right?
yeah, exactly right.
Okay.